Next up will be Kelly Michie from Biology, speaking on Gotta Screen 'Em All, discovering bacterial genes required for wound infection.
Can you imagine having an infected, painful, open wound that will just not go away? In fact, every year, 6.5 million Americans will suffer from a chronic wound infection. By definition, chronic wound infections take 3 months or longer to heal. One of the most common causes is a bacterium called Pseudomonas aeruginosa. Pseudomonas is associated with increased wound severity, prolonged healing times, and higher mortality rates. In order to develop more effective treatments for chronic wound infections, it is vital to better understand how Pseudomonas causes these infections on the genetic level. How do we do this? With genetic mutants. A mutant simply has a non-functional version of a gene, as represented by these different colors. Traditionally, researchers infect mice with individual Pseudomonas mutants, one at a time, and assess how each mutation affects Pseudomonas' ability to cause disease. However, these methods are very laborious, require large numbers of mice, and only a limited number of genes can be tested. For my research, I am instead using a new, highly efficient method called TNSeq. With TNSeq, I infect mice with a pool of hundreds of thousands of Pseudomonas mutants simultaneously. This allows me to test nearly all of Pseudomonas' genes and identify the ones that are important for chronic wound infection. Furthermore, while chronic wounds are relatively common, they are rare in normally healthy people. This is because both patient genetics and predisposing conditions, like diabetes, influence a person's risk. However, very little is actually understood about these interactions, because with traditional methods, often only one genetic background of mouse is used. The novelty of my research is that I am performing TNSeq with a panel of 16 different types of mice, each with a different genetic mutation that causes a clinically relevant immune or metabolic disease that is found in humans. This includes mice with diabetes, high cholesterol, and different immune system deficiencies. The outcome of my research will be a list of the genes that are important for Pseudomonas to cause chronic wound infections in mice with a variety of predisposing conditions. This information will be useful both for the development of new antibiotics and for advancing personalized medicine for patients with predisposing conditions. Ultimately, I aim to lessen the disease burden caused by chronic wound infections. Thank you.